Problem B6. The descriptors even, factors of 240, multiple of 3, odd, prime, and square are to be placed in some order as row and column headings around the grid positions. Around the grid in positions A, B, C, D, E, F. The digits 1 to 9 are to be placed in the empty cells inside the grid so that each digit satisfies both the relevant row and column headings. I show that it is possible to complete the grid. In how many different ways can the grid be completed? Let's try and complete the grid, okay? So we're gonna draw a big version of the grid and we're gonna try and see what we can do. Now we can observe that there are only 3 digits that are multiples of 3, and that's 3, 6, 9. We can place it in any order for now, just to show it's possible. Because it doesn't really matter, we just have to swap the descriptors around. Yep, okay. Next, we find there are 3 squares only, so we can put them in as well. So let me just write the headings. So this is multiple of 3, right? And I'm gonna write the column headings at the bottom for space, okay? The bottom, this is square. I'm just gonna write SQRE, I don't know why. Okay, SQRE. Now, what else can we do? Well, odd is one of the descriptors, and the only odd one left is 1. Because why can it not be in 3? Because it has to be prime. This has to be prime, right? Because otherwise, this column can't be prime. This column is already square. This row is, yeah, of course, it can be prime. This one cannot be, and this one cannot be either. Right? So that has to be prime, and this has to be odd because that's the only odd one left. Now, we can now do some stuff. In here, we can put 5 or 7. In here, we can put 2, 5, or 7 so far, okay? Now, what if we were to put 7 here in this bit? Well, what's going to happen is we find there's no descriptor left that includes 7 and 4 in itself. Therefore, 7 cannot go there. So 7 has to go here. It is forced. Now we also notice that 8 has to go here because it is not a multiple of 3. It's not prime. It is not odd. So it has to go in there. Next, we find that we have to put 5 here and 2 here. Otherwise, 2 cannot go in this area, right? Because it's not odd. So we have shown a possibility of completing the grid, as, yeah, I've just done. And this is one way of doing it, but how many ways are there? Well, before we get on that, we need to fill in the descriptors. This is even, and this is factors of 240. And that is all true. So now, how do we find how many times there are? To do that, I'm going to redraw the grid. This time smaller. When we inputted 3, 6, 9, there were actually 3 factorial ways of inputting it, and that is equal to 6. Therefore, we're going to have to do a multiplication of 6. When we inputted the 4 and 1, there were 2 factorial ways of doing it. So, 2 factorial is equal to 2. So we have to do 6 times 2, and that is 12. So far we have 12 possibilities. Next, we're going to place some objects, right? What other ways could we do this? Well, the important thing to note here is you could swap the entire order of the grids around. So you can move this whole row up here and put the 1 down here, right? And how many places can it go? Well, there is 1, 2, 3 columns and 1, 2, 3 rows, right? Therefore, we multiply by 6 to get 72, and that is our final answer. So the multiplication we just did, for clarification, is 6 ways of rearranging this, 2 of this, and the remaining is forced, but we can place the rest in 6 different configurations of row or column. And that is 72, and that is our final answer.